Formulated by Albert Einstein in 1905, the theory of relativity is the notion that the laws of physics are the same everywhere. The theory explains the behavior of objects in space and time, and it can be used to predict everything from the existence of black holes to light bending due to gravity to the behavior of the planet Mercury in its orbit. The theory is deceptively simple. First, there is no absolute frame of reference. Every time you measure an object's velocity or its momentum or how it experiences time, it's always in relation to something else. Second, the speed of light is the same no matter who measures it or how fast the person measuring it is going. Third, nothing can go faster than the speed of light. And so, how the theory of relativity impact the humans. We have a few ways of seeing Einstein's theory of relativity to humans. First off is electromagnets.
Magnetism is a relativistic effect, and if you use electricity, you can thank relativity for the fact that generators work at all. If you take a loop of wire and move it through a magnetic field, you can generate an electric current. The charged particles in the wire are affected by changing magnetic field, which forces some of them to move and create the current. But now, picture the wire at rest, and imagine the magnet is moving. In this case, the charged particle in the wire, the electrons and protons, aren't moving anymore, so magnetic field shouldn't be affecting them. But it does, and still flows. This shows that there is no privileged frame of reference. Thomas More, a professor of physics at Beaumont College in Claremont, California, uses the principle of relativity to demonstrate why Faraday's law states that a changing magnetic field creates an electric current is true.
Light. If Isaac Newton had been right in assuming that there is an absolute rest frame, we wouldn't have come up with a different explanation for light. Because it wouldn't happen at all. Not only would magnetism not exist, but light would also not exist, because relativity requires that changes in an electromagnetic field move at a finite speed instead of instantaneously. Moore from Panama College said, if relativity did not enforce this requirement, changes in electric fields would be communicated instantaneously, instead through electromagnetic waves, and both magnetism and light would be unnecessary.
Global Positioning System. In order for your car's GPS navigation to function as accurately as it does, satellites have to take relativistic effect into account. This is because even two satellites aren't moving at any close to the speed of light, they are still going pretty fast. The satellites are also sending signal to the ground station on Earth. These stations are all experiencing high acceleration due to gravity than the satellites in orbit. To get that pinpoint accuracy, the satellites use clocks that are accurate to a few billion of a seconds. Since each satellite is 12,600 miles above Earth and moves at about 6,000 miles per hour, there are relativistic time dilation that tacks on about 4 microseconds each day, and in the effects of gravity, and the figure goes up to about 7 microseconds. That's about 7,000 nanoseconds. The difference is real. If no relativistic effect were accounted for, a GPS unit that tells you it's a half mile to the next gas station would be 5 miles off after only 1 day.
Mercury is liquid. Similar to gold, mercury is also a heavy atom, which electrons held close to the nucleus because of their speed and consequent mass increase with mercury. The bonds between its atoms are weak, so mercury melts at low temperatures and is typically a liquid when we see it.
Just a few years ago, most televisions and monitors had cathode ray tube screens. A cathode ray tube works by firing electrons at a phosphor surface with a big magnet. Each electron makes a lighted pixel when it hits the back of the screen. The electrons fired out to make the picture move at up to 30% the speed of light. Relativistic effects are noticeable, and when manufacturers shaped the magnets, they had to take those effects into account. A CRT monitor contains millions of tiny red, green, and blue phosphor dots that glow when struck by an electron beam that travels across the screen to create a visible image. The illustration below shows how this works inside a CRT. The term anode and cathode are used in electronics as synonyms for positive and negative terminals. For example, you could refer to the positive terminal of a battery as the anode and the negative terminal of the battery as a cathode.